Hi team, this is another video on Snowflake. The subject of today is to build and deploy XGBoost model with Snowpark machine learning. So use case is in quick start intro to Snowpark machine learning. This is the link also for the Git code. Here we have the Snowpark ML modeling API. We have the client library and the server runtime. And we have the pre-processing to improve performance and the model training. And we use it in Snowflake Notebook, which is in private preview. It is not available yet. We have also the model registry, so you can develop and register your model and then reference it on Snowpark container service or on Warehouse. In this demo, we will use Warehouse. For the notebook, it will be available soon. And here we have the end-to-end machine learning. So we need to prepare data and train the data and make prediction. And also we can consume the result with Streamlit app. Here for the environment setup, we have on Snowflake side, we have the database, the schema warehouse, we have the stage, also the file format and the source file from Amazon storage S3 bucket. For the Python 3, so we have the following packages, and also it is highly recommended to upload and install the package from Anaconda, which is a certified repository, to avoid any mismatch of version when you deploy your local code to Snowflake. Here, the steps that we will do in the demo. So we have the data ingestion, we have the data transformation, data exploration, and model training, and making the prediction. We will use min-max scaler, which is a way to normalize the input futures or variable to min-max scaler. By doing so, all futures will be transformed into a range of 1 or 0. It is a requirement for machine learning. We will use also ordinal coding and one-hot coding, which will convert the category future to numeric. Sorry. Here, after here the API for the model pipeline pre-processing. And here we can check on Snowflake the version of the package. Here, for example, for the XGBoost, we have the version 1.7.3. And here I have some screenshots shots after the deployment of the model. Here we have some tables, metadata, some views, and the stage, and also the UDF procedure that is deployed when we have the deployment. And here some screenshot for the details of the columns of the tables. So let's start. Here also we have the stage, the list of the stage. There is stage to have the source data. It is S3 bucket, and the other is generated during the deployment of the model, and the registration also. So on my Visual Studio, we have the following notebooks. We have 3 notebooks. We need to clear all outputs. So the outputs here, we import the required packages and make the connection. Here we load in a data frame the content of the source table. We're using the delimiter, and we can also use the file format. So here we have these columns with this content. And here we have a summary of some metadata, the count and the mean and the max for each column. So we need to display the columns here. We transform the column header. Here we see that the column header are lowercase. So we need to transform the column header in uppercase, some basic transformation. See that transformation is done. Here we standardize cat columns just to have numeric and alphanumeric value with underscore. As you see here, we have some spaces and it is lowercase. Here it will be uppercase. See here you have ideal, premium, very good is uppercase and with underscore. Here we display the schema. We need to convert decimal type to Snowflake double type because it is not supported. Okay, and save back the content with the data frame write mode overwrite, and the table will be diamonds. Finally, for this Jupyter notebook, I close the session. And the second notebook Jupyter, we should also make the connection and import the required packages. Here we fix some variable, just the demo table, it will be from the current database and the current schema, which is already set up. Here we reference our source data. Here we need to categorize the normalize the cart column with decimal type, and we add also column carat norm to be normalized. Here we use the encoder function just to transform the numeric, the categoric column to numeric ones. See here the indexes here, which is, and we have the cut away and the clarity away here, which is numeric values to make easy the use of the model. Here also we transform the category to numeric columns for cut, color, and clarity. The output columns will be cut I, color OHE, and clarity OHE. Finally, we can also build this to build the pre-processing pipeline, and we have here the category column, OA, and numeric columns. This will create. Then we build the pipeline with futures. So this is the output. Now you can also save the picked object into the stage we create. Here we do some data exploration just to see the correlation between price and clarity. Here we have clarity and we have the depth. Here generate a graph of triangles with heat map. So here we see that price and clarity is highly correlated. And here we have also a plot to see the correlation between the price and the clarity. So this is the repartition of the price and carat. And finally, we close the session. The third model here, third Jupyter notebook, need just to clear the outputs. As usual, we import the required packages and connect Snowflake. I'm using JSON. It's okay. So here we load the data and we proceed the pipeline. Here we categorize the future for the modeling. We load the object locally, and here we build the regression model here. I will pause the video just because it could take maybe more than 1 minute. So here we have the split of the data for the test and for the training. It is 90% for the training and 10% for the test. Here we define XGB regressor to train and predict. Here, just illustrate that we can pass the data frame to Snowpark machine learning action. Okay. Now let's analyze the results. So here we have the price and we have the predicted price, and we have the percentage of error here. And here we have a plot actual versus predicted. We see that there is a high correlation between two. Here we change the size of the warehouse just to more performant comparison, because here we are using a grid search CV, which is a self-tuning for the model. So we will generate multiple models and we will choose the best one. It is auto done. So we have the estimator here and we have the rate. Let's see. So here it took more than 1 minute. Here we change back the warehouse to be small, and we'll see the best estimator here. Here the best estimator, it will be with the rate 0.4 and with estimate 500. Here we analyze the models. We'll see here the 5 models, and we have the 500 is the optimal one. Here we predict and analyze the results. Using the best one. So here we have the price and the predicted price, and we see here that the percent of the error is the best percent. Of the plot is the optimized one using the optimal model. Here let's save the optimal model and its metadata. Manage model registry. Here we will register the model. We need to have a model name, a model version, and we need to use the API with model registry. We pass the session, the database name, the schema name, and we need to replace if exists, and we log the model with this parameter. And finally, we set the metrics. So here it is done. Now we can just display the registry models. We have here role and environment. We have also the name of the model, and we have URI, and we have the version. Now for the deployment, we use registry.deploy to deploy the model name, the model version, and the deployment name. And the target method, it will predict. It is permanent. Now it is deployed, and we have details here. Now just we need to list the deployment. Have the deployment name is diamond price prediction 1 UTF. It is stored procedure. Here we reference the model and write predictions. Here we call the predict deployment model and test data frame. And we have the columns transformation that we done, and we have predicted price here. Here a little small test just to see that we can pass this data frame only for some values and get the required prediction, and this will be used in the Streamlit, because we will gather all the required input in a data frame and pass this data frame as parameter to the prediction model and see values. Here the prediction that is 318 according to this parameter. Here we do the cleanup just to delete the deployment and delete the model and confirm that all is cleaned. So here we finished with our deployment. You can see here we have the function here deployed, some tables. This is the source table, and I saved also the prediction for the predicted diamond, but the model will get any input just to have the prediction. Here I am trying to create a Streamlit application here just to use this model and predict the price. So you can create a Streamlit object here. It is you can also import the required package from here if you have any package required. It's so simple, just to click and you need only required package to be imported. Just I will pause the video. So here it is an application that take some inputs, all the required parameters, and when we click predict price, we need to have the price prediction. I'm developing this application to consume the output of the model. So that's all for today. Thank you very much and have a nice day. See you in another video. Thank you.